Hello, here in this video we're going to look at 4.2 powers of binomials. Here's the why. Mathematicians love fun patterns and things that seem confusing but really are very procedural. You will often see what we're going to learn about today called Pascal's triangle mentioned in mathematical riddles or puzzles. It is asked about occasionally on the ACT, and if nothing else, students typically find it to be one of the easier Chapter 4 topics, despite its intimidating look. And here's what it's all about. Powers of binomials is going to allow us to take down situations such as this. 3x minus 2 to the 5th power. And if you think about that, doing that by hand, that's quite a long process, because that would be 3x minus 2 multiplied by itself 5 times. I will do a smaller one here that we'll later reference back to, and that's a plus b cubed. So how could we do that with foiling? Well, it would look like this. We'd have a plus b, 1, 2, 3 times. Now, if you've never multiplied more than 2 terms at a time, like in this case we have 3, you do have to do 2 pieces at a time, no matter how many there are. So I'm going to start off with just these first 2, and I'm going to do the FOIL process. So a times a is a squared, a times b is ab, and then when I switch over to starting with the b of the first term, we get another a times b plus a b squared. So when we FOIL out that first piece, it ends up looking like this. And then we would take that result and multiply it by a plus b that third time. So I'll go ahead and list those out, starting with the a squared. So I'm going to take each of these terms and multiply by the 2-term piece right there. So we'll get an a cubed plus a squared b. Then when I multiply this one, we'll get plus a 2a squared b plus 2ab squared. And then for the final one, when I'm distributing the b squared, we'll get a plus a b squared plus b cubed. Now within this, there are some like terms. We have an a squared b here. Here's another set of a squared b. And then we have ab squared and an ab squared. So when we put these two together and these two together, we're left with a cubed plus 3 a squared b plus 3 ab squared plus b cubed. So there was quite a bit of work to that, and with that one being variables, it got a little confusing, perhaps for some of you all out there. So we're going to look at ways to complete this, leaving them as a and b, and we're going to take that in the pattern that we discover and see what we can do with it. All right. Well, anything to the 0 power from our rules of exponent is 1. Now a plus b to the first power is just simply a plus b. We saw what a plus b squared is up above. I'm going to put a star by it. It was this piece right here, which was a squared plus 2ab plus b squared. And then the third one, so a plus b cubed, was the final answer that we got at the end, which was a cubed plus 3a squared b plus 3ab squared plus b cubed. And believe it or not, there is going to be a pattern associated with these different pieces. And to find that, we're going to talk about the coefficients. And the coefficients are the numbers out in front of the variables. So that first one's just 1. Now the second column was second row was a plus b. So it was 1a and 1b. The third one was 1a squared, 2ab, b squared. That a plus b to the third power was 1a cubed, 3a squared b, 3ab squared, and then 1b cubed. So these coefficients are going to be the beginning of what's called Pascal's triangle, and it follows a very simple pattern that will allow us to take down situations such as this in a much faster way than multiplying it out by hand. All right, so the way the Pascal's triangle is going to work is going to be an extension of that coefficients that we just listed out up top. So if you kind of carry those numbers down, we're going to start off with a 1 up top, and then it's 1, 1, 1, 2, 1, 1, 3, 3, 1. And we'll pause here to allow you to see the different pattern that's going on here. Now, it does do 1s all the way on the outsides, so those are always going to be 1s. But to generate the other numbers, you may already see it's as simple as adding up the two numbers above it in the grid. So 1 and 1 is 2. 1 and 2 is 3. 2 and 1 is 3. So for this next one, 1 and 3 above it make the 4. 3 and 3 make 6. 3 and 1 make 4. And you can continue this on down and generate the whole Pascal's triangle. Generating it on your own on a test or anything of the sort is not very difficult. You simply start with the 1s on the outside and fill it on in. One thing that is tricky about it, though, because we're going to label out the rows, is that it's off by 1 in terms of what you'd expect. This first one is actually going to be row 0. All right, and you can see why, because anything to the 0 power just is a 1 only. So this one is row 1. This one is row 2. This one is row 3, 4, on and so on. Now, here's how you can easily keep this straight. If you notice, the row number corresponds to the first number that shows up after the initial 1. So if we skip over all of these 1s, the first number that shows up tells you what power you've taken it to. So this one is to the first power. This row represents the second. This row represents the third. This row represents the fourth, the fifth, sixth, seventh. So when you're taking something to different powers, that's how you know which one of these coefficients to take. So what we're going to see now is how to actually use this triangle to generate these answers. Because you might understand at this point that we've got, you might see this 1, 3, 3, 1 and see that 1, 3, 3, 1 right there. But you may be wondering, well, how does the variables work? How do the exponents work? So let's check it out here. It says use Pascal's triangle to expand a plus b to the fourth. So it's, the next rung down for us on this pattern. Okay. So what you will do is we're going to go to the row that has the 4 in it. So we want this row right here. This row will represent taking something to the 4th power. You can see the 4s in there. Now, leaving myself lots of space, I'm going to write out those numbers from the triangle. So we've got 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Okay? A good thing about this is that they'll all start off with plus signs in front of them. Okay? Then the remaining part is you take your variable that's on the left, so in this case, a, and you start it all the way on the left to the exponent. So on this one, we are doing a to the 4th power. And then as you move it to the right, it will decrease by 1 each time. So then we'll get a to the 3rd, a squared, a to the 1st power, and then no a's. You'll know you did this right if you run out of variables one more before you get to the end. Now you take your variable that started on the right, and it starts on the right to the exponent. So I've got b to the fourth, b to the third, b squared, b, and no b. So this is the correct answer for what you'd get if you did a plus b to the fourth power by hand and you gathered and combined all of your like terms. You would get this as your answer. So this is why on the, up here I said it looks very difficult, but it's actually very procedural. Once you know these numbers, you are then just labeling out your variables and counting up and down. It is, it's a step-by-step process, and it makes you look like you're very talented and can understand vastly complicated, powers of binomials. So when we're doing one here to the 8th power, it's going to be very large, but it's going to be simple and procedural. Now, you might notice here that we don't have the numbers for this. We'd have to go one more rung down on our triangle, and that's okay. And you will notice that these are symmetrical, as in like that 70's in the middle and it branches out from that. So we're going to take those numbers, leaving ourselves plenty of space. 1828. 56, 70, and then it starts to scale back down. So we have 56, 28, 8, and 1. Okay, now we simply take our variables. So I'll start with a, because it's on the left, to the 8th power. So a to the 8th, a to the 7th, a to the 6th, a to the 5th, a to the 4th, a to the 3rd, a squared, a, and I know I did it correct because I ran out before I got to the last one. Then we start with b on the right, b to the 8th, b to the 7th, b to the 6th, b to the 5th, b to the 4th, b cubed, b squared, b. As you may notice, all of the exponents add back up to the initial sum. So 8 is 8, 7 and 1 is 8, 6 and 2 is 8, 5 and 3 is 8. That's another way of double checking your work. And then all of these have plus signs in between them, which is why I try to leave myself more space. All right? And so that looks like an absolutely crazy answer, right? It looks like generating that would be extremely difficult. However, each step along this process is quite procedural, quite basic. We generated this triangle by simply adding numbers. And once we use those numbers, we're just counting down from 8 from both directions with our variables and tossing in some plus signs. Now, as we look at this again in another part of the lesson, or as you try some, there are some other things to consider, such as negatives, such as when there's other numbers in addition as well. But that'll be one that we explore separately from this video.